Chapter 6.6. Which is solving logarithmic equations. And we're referring here to solving them algebraically. So log base 2 of x is equal to 3. And again, we're going to be using the properties, whatever property necessary. This is simply x is equal to 2 to the power 3. So x is equal to 8. Okay. Log base 4 of 5x is equal to 2. So 5x is equal to 4 to the power 2. So 5x is equal to 16. So x is equal to 16 over 5. Log base 4 of x plus 6 is equal to log base 4 of 14. Observe that the logarithm bases were 4 in both cases. So this simply implies that x plus 6 is equal to 14. So x is equal to 14 over 6. 14 minus 6. 14 minus 6, so x is equal to 8. Log half, I'll come back to that one. Log base x plus, no, let's take this as just a plain logarithm. Log base 10 of x plus log base 10 of x plus 3 is equal to 1. Remember, we said that if the base is not given, then we would assume that the base is 10. So this means that x into x plus 3 is equal to that implied base of 10 to the power 1. Distributing, we have 10. So x squared plus 3x minus 10 is equal to 0. And factoring, we've got x plus 5, x minus 2 is equal to 0. So x is equal to negative 5 and x is equal to positive 2. And notice that if we substituted negative 5 into the original equation, we would be trying to take the logarithm of a negative number, and so we have to discard this answer. However, 2 works. Okay. Cannot take the logarithm of a negative number. Log base 3, x plus 11 plus log base 3, x plus 5 equals to 3. So combining the two logarithms on the left-hand side into a single logarithm we've got x plus 11, x plus 5 is equal to 3 to the power 3. Foiling on the left-hand side, we've got x squared, that's 3x plus 11x, which is so yeah, I kind of lost my way right there. This is 5. So 3x, x squared plus 16x plus 55 is equal to 27. So x squared plus 16x plus 28 is equal to 0. Factoring, I've got x plus 14, x plus 2. So x is equal to negative 14 and x is equal to negative 2. Now notice substituting negative 14 gives log base 3 negative 14 plus 11 log base 3 negative 14 plus 5, which means we would be taking logarithms of negative number. So it's negative 9. So x is equal to negative 14 must be not a solution, not a solution. However, if we substituted negative 2, we get log base 3 of negative 2 plus 11 plus log base 3 of negative 2 plus 5, which means both cases we will be taking the logarithm of a positive number. Okay, that will be log base 3 of 9 and log base 3 of 3. So both cases would result in us taking the logarithm of a positive number. So x is equal to negative 2 is a great answer to this. Two log base 5 of x is equal to log base 5 of 25. So using the power rule, we have log base 5x squared is log base 5 of 5 to the power 2. So x squared must equal to 25. One second here. Yes, we were here. So x is equal to plus or minus the square root of 25 or plus or minus 5. However, we have to discard the negative answer. X cannot equal to negative 5 since we would be taking logarithms of a negative number. So the only answer is x is equal to positive 5. if you're asked to solve something like, say, 2x, 2 to the power x is equal to 9, then the process here is to go ahead and take logarithms on both sides of the equation. So you want to be really careful with that process. Okay? Take natural logs 2 to the power x is equal to natural log 9. Now, if you bring the x to the front using the power rules, is x ln 2 is equal to ln 9. And then divide both sides by ln 2, so x is equal to logarithm 9 over logarithm 2. This is the exact answer. And if we put this into a calculator, you can get an approximate answer to the problem. Okay, you can put that into the calculator is logarithm 9 divided by logarithm 2. What am I doing? Logarithm 9 divided by logarithm 2, and get the answers approximately 3.17. A couple more examples with this. So if I have, say, 7 to the power negative x is equal to 2.2. So again, taking logarithms on both sides. So negative x ln 7 is equal to ln 2.2. So negative x is equal to ln 2.2 over ln 7. So x is equal to negative ln 2.2 divided by ln 7. One second, please. Okay, I'm back. So this is ln over ln 7 would be the solution set to this problem. Okay. FYI, there's a couple of other ways to do this, and this is where I want to mention the change of base formula, which says that log base A of m can be written as log base B of m over log base B of A. I'm showing you this formula because if I were to take this same problem, 7 to the power negative x and 7 to the power negative x is equal to 2.2, and rewrite it in the logarithm form, it would be log base 7 of 2.2 is equal to negative x, so negative x, so x would be equal to log base 7 of 2.2 minus, and then if we use the change of base formula, this would be log base 2.2 over log base 7 of 7. Sorry, I got this problem mixed up. This is natural log, not logarithm, natural log 7. So yeah, ln 2.2x so we can just use the logarithm. Logarithm 7 of I had this right in the first place. I don't know what I'm doing. Is equal to negative x. X is equal to negative log base 7 of 2.2. I absolutely had this right. So x is equal to negative log base 7, 2.2 over log base 7. And at this point, this would be a change of base. Okay, it will no longer be base 7, perhaps log base 10, log base 3, or something like this. I also wanted to demonstrate the change of base formula. So if you're asked to find log base 6 of 31, this rule says this is log 31 divided by log 6. Okay, so calculator would give you the solution to this, and I want to show you two different ways. So we're taking log 31 divided by log 6. Log 31, make sure you close the parenthesis, divide by log 6. And you'd get your answer is approximately 1.917. FYI, some of the neural calculators have a feature built into them under the map button. And if you scroll down, you would see log base. And this actually allows you to type in the base and the number 31 and get exactly the same answer. Okay, and again, it doesn't matter if you took a natural log you would still get exactly the same answers. So I just wanted to throw this in there. Let's go ahead and capture the screen. And that ends what I have to tell you about today. So we're going to stop the video.